Next up, we have Ed Gernard, which is a co-founder and vice president of engineering at Frontier Design Automation. I think Frontier may be our newest member, if not our second newest. But they joined recently, and they're already contributing to the coalition. If any of you are OpenAccess Windows users, we have a new procedure for building OpenAccess on Windows that Ed has voluntarily contributed that you can get that procedure off of the member portal. And thanks for that, Ed. And the presentation is designing a new shape-based AutoRouter.
Good morning. My name is Ed Gernard, one of the founders of Frontier Design Automation. Today I'm going to talk about designing a new AutoRouter. And by the way, the little guy at the bottom is Bob. He's a manual layout guy. And he has some ideas on this also. For your wish list for designing a new AutoRouter, it needs to be no complex router setup. Constraint aware, needs to be flexible. You need to have MST, minimum spanning tree, and also spine backbone. It needs to avoid obstructions and understand congestion. It needs to be high performance, and of course, while we're all here, for reading, writing, OA. For setup, what I've typically seen routers do, they have a lot of setup switches, and they get passed from one design to the next design. And at some point, you ultimately don't understand what that switch is for. We think that all the strategies and the switches should be automatic. So whether if you're routing a standard cell design, a PCB, or a block, the system should automatically determine what style that is and set it for you. All the constraints should be defined in OA. Any user preferences or non-OA constraints could be defined outside of it. And basically, you just hit auto route. No hidden switches, no black box. Everything should be transparent. Should have a full user with debug GUI to show the progress as it's routing. You should be able to pan, zoom, measure, query, inspect the routing as it's going. And then the big thing is providing meaningful feedback for the user. For any advanced node design, the router checker typically deals with at least 200 flavors of constraints. So the router needs to be aware of all these constraints as you're routing. The benefits of having a shape-based router is you actually model the shape geometries that represents the devices, the paths, the interconnect vias. You can have unique widths and spacings per class, net, object, shape, and you actually check the physical shapes and the area shapes with no approximation. However, the challenges are storing the millions upon millions of shapes, the accessing of shapes in a given area, and the big thing is performance. If you have to manage all these millions of shapes, how do you do it in a timely manner? For shape expansion, typical shape expansion, you're expanding from the source to the target. You seed the source with north, south, east, west expansions. That goes into a priority queue, and they come out based upon a cost. For instance, the top east path, when it comes out, it would propagate north and south, go back to the queue. The south one would come out at some point. It would go east and west and hit the target. And basically, an oversimplification, but you're done. For any given expansion, the router has to look at the area around that, and it will need to query all the shapes. And based upon those shapes, it will fracture the shapes and then put them back into the priority queue again. As an example, here's a 1,000,000 connection standard cell design. The number of shapes that came out of the database for evaluation was 33 billion. Just something that we always monitor all the shapes. And Frontier Design routed that in a little over an hour and 12 minutes to route the whole thing. So you can see how many shapes came out and the complexity of the shapes. For data path or high fan-out nets, for optimal routing, you need spine or backbone. This will reduce the overall routing resource and it improves electrical characteristics of the net. You have less vias. The spine is typically on an upper layer, a wider layer metal. For Frontier, we generated and detected almost 7,500 spines. Took 11 seconds, averaging 20 pins per spine. And basically on this 1 million connection net, that's 14% of the total connections were done in spine. And the router takes a couple of minutes to route the spines. For any given router, the typical router does global, and it does possibly some track routing, and then it does the detail routing to finish up. We think that a router should automatically avoid blockages as it's routing and understand congestion. For the Frontier router, it's built in, and we have something called Assist that will automatically detect blockages on the fly. For this little design on the right, we routed in 4 seconds and then another 2 seconds for clean. So it understands blockages as it's routing. About Frontier, John Cooper, as you may know from Cooper and Chan, and myself founded in 19. It's designed to handle all sorts of styles: standard cell, mixed, chip assembly, PCB, interposer. And 2 out of 3 vendors use routers written by the founders. Cadence still uses Spectra and IC Craftsman. It's interesting, 30 years later, it's still relevant, and there's customers still using it. When Magma was around, its Galaxy router was written by TerraRoute, which was a prior company to this Frontier. And Synopsys uses TerraRoute/Magma, since they were both bought by Synopsys combined, and that's their custom compiler router today. We have a patent pending high capacity, high performance shape-based utility. Where we are today, we've done the shape storage and database mechanism, high performance and capacity. We route, see the third line down, 2 million connection design in 8 hours, standard cell, 9 metal layers, proven expansion algorithms. It's congestion and blockage aware. You don't need to run any prior global or anything. It knows all about that. Does spine routing, MST, constraint support. This is an ongoing problem that all AutoRouters face. Today, the chart on the right shows where we are. There's some in progress items. They'll probably always be in progress since the new rules always change. We have a user and debug GUI, and we support OpenAccess. And where we are today, we're actually looking for help from customers to help define and verify user foundries constraints. So we're looking for some companies right now to help our routing technology. We want to partner and help you also, possibly for advanced node, packaging, integrated fan-out, special rules, constraints, unique topologies. You'll get fast turnaround. You'll get access to developers and early code release. And we have a new website we're launching today, frontierrouter.com. As Marshall alluded, we spent some time early on building on Windows, and I captured all the steps to building on Windows for Virtual Studio. And there's a link at the bottom that's on OpenAccess, but this is basically the steps that we followed to creating OpenAccess on Windows. And thank you very much for allowing us to present and showcase our new product. And again, frontierrouter.com. That's all I have.
Any questions?
Yeah, I
Good
have one
question.
question. It may apply to other tools presented as well. Do you find that the OA constraint model is sufficient for all the types of constraints that you'd want to support?
That's a good question, considering that we're still into the constraint territory. So as of now, yes. Probably in the future, no. There'll probably be some constraints that will need to be added to OA.
I can answer that for PulseSic as well, if you like. It doesn't have all the constraints that are necessary to represent the design rules, particularly at the lower process nodes. So it has at the higher process nodes, the larger process nodes, it's pretty complete. But if you get down to like 22 nanometers, there are many rules in the PDKs that aren't representable in OA or aren't typically set up in OA. It would be great to see more of them there. It really would.
Hi. So this tool is just focusing on the routing part of the problem. It's not doing placement or anything like that.
No, it's just the routing part of the program.
And
yes.
I'm more of an analog person, so I'm sort of asking on behalf of my digital colleagues. But does part of the process is feeding back information from timing analysis? Isn't that right? So you do an initial route, and then you'll analyze it for timing, and then it might identify problems. Do you have a mechanism for? I mean, do you have a mechanism for incorporating that feedback?
We would translate that timing into a length, a physical length for routing. So that would be whether it's match length or min-max length.
And that would be a constraint.
Yes, it would be a constraint.
Okay, I get it. Okay, thanks.
Sure.
Hi, Ed. This is Sandra Kupperman from Mentor. Actually, Siemens EDA, excuse me. I had a question regarding your slide on open access on Windows. What was the reason for open access on Windows?
Because we are doing our design development on Windows platform using Visual Studio.
Okay.
For us. We're using just basically C++, so we can compile anywhere. But the Visual Studio platform is so much easier than anything on Linux to develop on. It just makes life a little bit easier. That's all.
Yeah, we've seen those challenges as well with the Tanner EDA project, which is built initially on Windows. But in the CAD, in the EDA world, all designers, CAD people, are all on Linux. So how do you make that seamless so those people do typically just run Linux all day long?
Yeah, this was just for us for building on Windows. We plan on porting the software over to Linux at some point. Right now it's on Windows. The GUI is written on OpenGL, so it's portable. There's nothing we're doing that's unique to Windows at all, except developing on Windows, just for the ease of use.
Ease of use, okay.
Yeah. So we will port to Windows. We can even port to the Apple computer. One of the things my John Cooper wants to do at some point, but that's a low priority.
No, I can
so there's nothing that we're
doing.
iPhone. Yes. You never know.
So when do you expect to have it on Linux?
Probably shortly.
Okay. And
we're looking for customers to help us. As I said, we've just started this 2 years ago. We made a lot of progress, and we're at a point now that we're looking for customers to help us determine some unique challenges that they're having and how we can solve those, as well as getting all the constraints. Mark alluded to all the constraints below 20 nanometers. They're not documented anywhere or supported by OA. So we'll have to get some of those constraints and be able to put them in the router. It just worked for us right at this point. I don't see any big obstacles. But for Windows, if you look at the documentation for OA, I think it was like 2006. Visual Studio was last supported on Windows. So there's a lot of changes that have happened on Visual Studio. So these are basically the steps. It'll save you a week's worth of scratching your head, probably.
Is there any plan to read like Tickle? We have the left def flows where we have everything defined with tech left, and now a lot of tech lefts are now moving to Tickle based, defining of the technology and all the rules. Is there any plan to read those into your environment?
Not today. Can those get stored in OA?
Oh, no. This is just, well, no, because they're running it. You're coming into Nitro and with the router is the one I'm working on right now. But there's also Prisa. But no, those are all the internal databases.
Yeah.
So you're just going to run on OA directly, I guess.
Well, we're going to read OA, read all the constraints we can, and if there's an external file or something that we need to read, that we can surely do that. It's not a problem.
Yeah, you might consider looking at that. Well, I don't know.
I think it all depends on who we would get in partner with. If that was one of their requirements, that's not a problem.
I understand. Okay.
So it reads OA, but will it produce? What will the format of the output be? Will it produce routing in OA, or will it be some other kind of format?
OA. It would all go back to OA.
Hi Ed, this is Rami. I just am curious to know which version of OpenAccess did you migrate to Windows?
The latest.
The latest.
2.3, 2.2. Marshall, help me out.
Including or
2260 patch level 50.
We were on the absolute latest.
including partitioning also?
Yes.
Okay. Thank you.
Could this tool be used for, say, in a analog block to do interconnect between sort of large analog blocks?
Yes.
Actually, you had a slide, didn't you, where you had routing going around obstacles. Can I have a look at that again?
Here's a block type routing. So what I did was I just selected a few of the nets that go around a block, and I called the router on those. Right.
And would it do things like automatically insert buffers and so on if it thinks the path is too long?
Not right now, but yes. I think inserting buffers would easily be done. What I'm showing here is the automatic detection of the blockage. And it's built into the router as well as congestion. So as you just hit the route button, it doesn't matter if you're routing a block or a standard cell or even a PCB design. We have some demos on our website if you want to go look at some of the actual routing of the different types of designs.
Okay. Okay, thanks. It's interesting.
Sure. I have one more comment. On our website, there is a contact us if you want more information.
Okay.
So
I'm posting questions to my digital guy here. He's asking, does it need timing libraries, Ed?
No.
You use these length-based constraints, so you don't.
It would be a physical constraint, yes.
Yeah. Okay. Thanks.
The only remaining thing is to say thank you for attending, and I hope you enjoyed the presentations.